Hello and Assalamu alaikum everyone. Hope you all are doing well and are keeping safe. This is Sir Iman who will be teaching you computer studies for the years 2020 to 2021. Let us start with our very first lecture of this subject. Chapter 1: Binary Systems and Hexadecimal Systems. Now, even though when we used to study in physical classes, I used to first explain the name of the chapter thoroughly before starting each chapter. But now, in order to not cause any confusion and make sure that you understand each and everything properly, we will just go with the flow and study as these slides go on. So, in this chapter, you will learn about the following things: the binary systems, measurement of computer memories, the hexadecimal system, how to convert number systems between different number-based systems. Okay students, let me give you a brief introduction of this topic. Number systems that uses only two values, 0 and 1, to represent codes and data. Since zeros and ones can be easily represented by two voltages, the binary system is the foundation on which digital technology is built. Now students, remember this one line: binary system is the foundation on which digital technology is built. It means that all the digital technology that we now see in this era has a base, or you can say foundation, of binary system. Everything is built on the basis of binary system. Every digital computer, whether a pocket calculator or a mainframe, uses the same binary notation. It means that irrespective of the size of computer, the binary system is there to lay the foundation of a digital computer or digital technology. We have 2 points in front of us which say that the basic building block on all computers is the binary number system. Second says this system is chosen since it consists of ones and zeros only. So, since computers contain millions and millions of tiny switches which must be in the on or off position, this lends itself logically to the binary system. So this binary word is because of these two options, these two positions, on and off. A switch in the on position can be represented by 1, whereas a switch in the off position can be represented by the word 0. The binary system is not strictly based on electric switches and computers, but in the end, binary, just like decimal, hexa, octa, etc., is just another way to represent a concept, the concept of numbers. Students, it just happens that binary is a great match for the digital computer as of the modern age, and more specifically for the transistors that make up a digital technology or a digital computer. Now, the binary system. We are familiar with the denary base 10 number system, which counts in multiples of 10. This gives us well-known place of units, zeros, hundreds, thousands, and so on. And as you see in the table below that I've drawn, each number has a place value, so 1000, 100, tens and ones. So you can see how this table is based on the decimal system or denary system. Okay, so as I've explained in the previous few minutes that the binary system is based on number 2, so it only has two values. Let me repeat this again. It only has two values, 0 and 1. These two values can be used in the system to represent or to present each digit. This gives the headings of 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, and so on. So the way we write 1, 2, 4, 8, 16, 32, 64, etc. and so on in normal numbers, we don't write in the same way when writing in binary system. For the table that you're seeing in front of you right now, the typical binary number for this would be 11101110. So now students, as you all know that we are studying this chapter from the book that you have been provided by the school, Cambridge IGCSE Computer Science. So if you open your book and see this first chapter, you will find this heading on page number 3, Converting Binary to Denary. So as I've explained in the previous few minutes about what is binary and what is denary, now I want you to open your book and see that there is a table named as activity 1.1, and in that table there are a few questions given. So if you attempt those questions, you will better understand how to convert binary to denary, or this whole topic that what is converting from binary to denary. It is fairly straightforward to change a binary number into a denary number. You know, each time a 1 appears in a column, the column value is added to the total. And the one thing that you have to take care of always is that 0 values are simply ignored. Now, converting from denary to binary. The reverse operation of converting from denary to binary is slightly more complex. There are 2 basic ways of doing so. Okay, so in method 1, consider the conversion of the denary number 107 into binary. This method involves placing ones in the appropriate position so that the total number equates to 107. Method 2. This method involves successive division by 2. The remainders are then read from bottom to top to give the binary number or binary value. Again, using 107, we get the following number that's written on the screen in front of you: 011011011. I repeat, you have to read the number, read the remainders from bottom to top, as you are seeing these numbers written in front of you. Thank you for listening to this lecture. Stay safe, stay home, and Allah Hafiz.